All right, guys, welcome to another KevCAM night class tonight. Tonight I have Mr. Scott Harding helping out. Scott, are you there?
Oh, I'm here. I am here. Thanks, Kevin. We appreciate everyone coming out to or joining us virtually here for KevCAM tonight. We see we've got some familiar names and some of you that seems like are joining us for the first time. So welcome to both of you. We really enjoy doing these sessions and providing a little more information and continuing education for SolidCAM.
Yeah, absolutely. Thanks for the introduction there, Scott. Yeah, for all you guys that are new, we are using GoToWebinar to do these night classes, and these night classes are solely dedicated for you guys. So over on your guys' control panel in the GoToWebinar, there'll be a spot where there is a questions panel. If you guys run into questions as I'm going through this, going too fast, want to look at something different, definitely type those in there, and Scott will ping me and he'll stop me dead in my tracks, and we'll get those questions answered for you right away. And like I said, I want to focus these classes just for you guys, so if there's something that I'm not covering or went over too fast, definitely let me know. And then with that being said, too, definitely send your ideas over to us. I know a little bit of a refresh here, but if you guys send me a topic, you'll get some SolidCAM swag, and we'll send, we'll use your part, or user suggestion, and we'll make a whole night class out of it, or we'll just make a quick tips and tricks video for you guys on the YouTube channel. For those of you guys that don't have my email address, let me put this in to the chat for you guys, and everybody should be able to see that now. Also, all of our night classes are recorded for everybody that is new tonight, and they are recorded up on my YouTube channel here. And if you guys type in KevCAM or you type in SolidCAM University, my ugly mug should pop up for you guys. But I will put the link in there for you guys also here. And there you go. So that will take you to the YouTube channel. In here, have tons of tips and tricks. Actually, just did a product review on the 3D Connection mouse, and how to make it a little bit easier life for you guys. But yeah, tons and tons of videos in here. All the night class videos. A lot of stuff in here to help you guys out. And like I said, if there's something in here that you guys want to see, definitely shoot me an email, and we'll get that added in there for you guys. So. But I guess with that being said, we'll get going with tonight's class. Tonight is going to be HSS, morph between boundary curves and morph between adjacent surfaces. These are actually two of my favorite toolpaths in HSS. Well, actually on all 3D, just because you have so much more control when you're doing morph between boundary curves, stuff like that. Now, do we have, let me just look through our list here. I was going to wait until, so last week we were talking about adjacent surfaces, or I'm sorry, perpendicular to a surface. And it kind of got to the point where, we came up with some good examples, but in real life world, I couldn't come up with something where I would see a benefit out of it. And actually, Ronnie Kidder sent me over a picture. And unfortunately, Ronnie, I don't think is here yet, but I'll bring this, open up this picture here for you guys, and it's just a little screenshot. And what he was actually doing here is he was working on this radius right here, down here at the bottom, and he was actually doing a morph on this bottom, and kind of what we're going to be covering today. But you can see he's getting a lot of retracts coming up and down over here. And so what he did is he switched it over to perpendicular, and you'll see it really cleaned up the toolpath. And unfortunately, I don't have the try to zoom in here for you guys, but you can see right here we're not getting that jumping around like we were up right here. So he sent that screenshot over so you can kind of take a look at it. But definitely, you guys have any parts or stuff like that you guys want to show, definitely let me know and we can show those on here. So for those of you guys that were in the last week's night class and we're going over that, here's a good example right here. So okay, so we'll get ball rolling here. So first thing I want to do is kind of leave off as parallel to curve, doing the exact same parts and kind of show you the difference between, using parallel to curve versus morph between two curves. So what we'll do is just get going here and go to HSS, and we'll just do parallel to curve. And my drive surface is the surface that I want to cut. So I'm just going to grab my surfaces real quick. Okay. And my edge curve, I can pick either the left side or the right side here, but I'm just going to grab this left side, and we'll just continue that right there. And let's go ahead and grab a cutter here. And I'm going to skip levels like I normally kind of talk about. After I grab my tool, I'm just going to do save and calculate, and let's just see what we have so far here. So we got a lot of bouncing around first. So what I want to do is I'm going to get that kind of cleaned up first. So like we've talked about in the past, is that's going to be in your links section. So let's go ahead and clean up our links. And for this top one here, we'll just do follow surface. And for this bottom one, we'll just do like a blend spline. And this should clean up all of our retracts. So yep. So now we got our retracts all nice and cleaned up. But here's the one disadvantage of using parallel to curve on a particular surface just like this one. If we do a top-down view, you'll see that we're kind of going along with the surface right here of that edge line, but as it kind of gets going out, it kind of fades away. So if we do kind of a top-down view for you guys here, you can see we got a nice toolpath on the left, but once we get over to the right side, we're not looking as good as what we should be. So to accommodate that, that's why we have the morph between boundary curves here. So let's go ahead and exit out of here, and let's do a morph between boundary curves. Geometry, and I can just grab that geometry that I grabbed before, or I can just click on the surfaces, doesn't matter. And I need to switch this over to morph between boundary curves. Sorry about that. Okay, so your start. Now the start is where do you want to start your cutoff, and basically the end is where do you want to end the toolpath at. And so for my start edge curve is I'll just grab this line right here, and basically what I'm telling it to do by clicking that start there is I'm telling it to start over here and work its way over to this side. And the toolpath will actually follow along those curves of that surface. So we'll come over here, and we'll do our end. Okay, so now let's go ahead and grab a tool again. And toolpath parameters, we'll just do a save and calculate and see what we're looking at here. So what we'll do here is we do have a little bit of retracts you see just at the front half right here. So let's just go to our links, and I'm just going to do a same thing as what we did before, follow surface and a blend spline. Okay, so that will clean up that toolpath. And sure enough, Ronnie shows up. Ronnie, I was just talking about you in your part, showing them the part that you ran across. But okay, so now if we do a top-down view of what's going on here, is you'll see over here like we're following along, but since we're doing a parallel to that curve, as it gets over here, it gets kind of scattered. We're morphed between two curves here. Is you'll see the toolpath really follows along the entire geometry right there. So as we kind of go back and forth right here, it's following along that surface just perfect. And you can kind of see following along here, just kind of working our way down, up and around, going all the way through. Now, like I've said before, is, get your guys' toolpath looking the way you want. Grab your geometry, grab your tool. do a save and calculate at first, just to see what you got, and then come over to your links and straighten out any, you know, you guys can do follow surface, we could do blend, you can do direct, but definitely come in here and get those cleaned out. And then last thing, like I say, is come over and tighten up, excuse me, your maximum step over right there. So, so if we're looking for a nice finish here, we can just do 10 thou. Save and calculate, and now we're going to have a real nice finish going through that entire part. And like I said, following along that geometry. So like I said, your start curve is where do you want to start the toolpath, and your end is where do you want to end it, and it's going to follow those curves exactly. So really easy to use. Like I said, this is kind of one of my favorite ones just because you have so much control right here. I also like using this one if you had like a radius around the entire outside of a part. What I would actually do for that one is, you know, your start would be the top of the radii and your end would be the bottom. And then what I would actually do is come over to my toolpath parameters, and instead of doing a zigzag, I would do a spiral. And we'll actually cover that spiral one next. But any questions on this particular part right here and the kind of comparison between parallel to curve versus morph between two curves? Okay, perfect. So let's go ahead and we'll go to our next part here. And grab this guy right here. So what I'm going to kind of do is kind of go along the same lines here. Is I want to do a parallel to curve and show you guys the difference, and then do a morph between boundary curves. So for this one right here, we'll just do a parallel to a curve. And I'll grab my 3 surfaces that I want to cut here. And my edge curve is going to grab the bottom right here. And I already could have picked the top. It doesn't really matter here. Now tool. And like I said, let's just do a save and calculate and see what we have going on here. So definitely getting some retracts here going on. So I'm going to get those kind of cleaned up first. So if we go to our link section and links here, and for this one, let's see, let's just try doing direct, and let's just do a follow surface. And I'm just going to kind of push this part over here. Okay, so.
And
yep.
Kev, Mr. Kidder just added on the question list that they can also create their own curves if they want, if they don't like what the model has.
Oh, absolutely. Yeah, great point there, Ronnie. Like on that last part, if you guys don't want it to follow that exact line edge, you know, on the left side or right side, you guys can definitely draw in, do a quick sketch on a geometry and draw that in also, and use that as your start and end is kind of also your guide curve too. So definitely you can draw that in there and you know, get it so it's working the way it's following what you want as a process. So. Yeah, thank you, Ronnie. A great point there. So now you'll see, and I can clean up this a little bit better here. You'll see that I'm just doing a direct step down, starting at the top, working my way around here. Now, if I go to my toolpath parameters, like I said, we'll switch this over to spiral here. So we're spiraling down on the part, but you'll see it's not an optimal toolpath. We're kind of coming up over this flat where we have already cut. So to fix that, what we can do is just do the morph between boundary curves. So what I'll do is grab our morph between boundary curves here. And I can grab that same geometry here that I just picked. Now I'm going to turn off that toolpath, and my start is up here, and my end is going to be down here. So this is where it really comes into factor is since this this island is kind of sitting up at an angle, this really comes into factor of your maximum step over. So I'll get some toolpath on here and show you what I'm talking about here. So right now, looks like our links are good to go here. To clean up our toolpath just a little bit and get a little bit more proficient in here, instead of just going around and then stepping down, going around and stepping down. I'm going to get it so it stays in contact with that material, and the transition will be much smoother. So I'm going to switch it over to spiral here. Okay, so you'll see how much nicer that toolpath is looking, and it's following the surface of what's going on there. So we have a, basically a straight up and down start and a kind of an angle or a oblong at the bottom here, and the geometry kind of contours to it. So over here, our step over, when we have our toolpath parameters here, our max step over is set at 50 thou right now. So we might have 50 thou over here, but we might have something a little bit smaller over here to accommodate that. Now, kind of looking at this part, you'll see if we get a side view here, you kind of see we have a gap going on right here. And that the only reason we have a gap right there is what's happening is we're working on the tip of the tool towards the top, and then as it moves down the side, we're working on the side of the cutter. So definitely don't be alarmed by this at all. It's just because it's switching the contact point. Now, if I wanted to lock it down, I could do it just at the radius, or I could just do it at front. But since it is set to auto, it's automatically going to switch over. Now, it looks pretty significant right now, but you got to remember we have a pretty large step over. So when we come back in here and go to finish this up, if we do a 10 thou step over, we have a nice clean toolpath going around here. And like I said, you'll still get a little bit of a gap right here, but it's just because it's changing the contact point of the tool as it's working around on that radius. So like I said, we're working more of the ball, the tip of the ball down here, and then switching over and moving over to the side of the ball going down right here. So does that kind of make sense for everybody? Now, if we wanted to also, if say we don't want to touch the surface at all right here, so we can come over to our gouge check, turn on our gouge check and tell it to, not to touch, this surface right here, which shouldn't be touching right now. We do a trim and relink. There we go. So guarantee it's not going to move into that bottom half right there. Now, as I'm kind of going through this, I know we have quite a few new guys in here right now. Now, all these buttons that I'm kind of going over a little bit quick here, like the trim and relink. For those guys that are new, I did do the first night class of the HSS going through what all these buttons do and all these features do. But as I'm kind of going through this, if you guys do have questions, definitely let me know, and we can address those right then and there. But like I said, if you guys are curious on what every single little button does inside HSS, definitely come back and watch that that intro video that we did. I think we shot that 3 weeks ago now. But okay, so any questions on the difference between parallel to curve versus morph between curve and when you'd use it, or anything like that with this part? Okay, so let's go ahead and carry on to our next part here. And this part right here, I think this is the one I want. Yep. Okay, so you guys will remember this part from when we did the constant Z and linear path, and we didn't get into the bottom half, and I told you we'd kind of come back and show you that. So what I'm going to do here is I'm going to kind of break this up into two parts. And you don't always have to break it up, but you know, what I'm going to do is kind of break this up and I'll show you the difference of what's going on here. So we'll just do a HSS here, and we'll do a morph between boundary curves. Now my geometry, I have it somewhere in my list here. And we'll do a start right here. And an end right here. And just give me 1 second here, guys. So actually what I'm going to do is I'm going to add this one in here. Okay, so my start, I think I already grabbed it, but and now my end is going to be down here. So we got our hex and a round. Let's go ahead and grab a cutter here. And this particular one, I'm going to want to do it as a spiral. Okay, so here is a little bit of an oddball example, but this is kind of something I wanted to show you guys here is when we are doing this, you'll notice that if we come straight down on the part here, you'll notice that hex portion is really working its way up. It's working up too far. You'll see we're getting a little bit of you know, retracts going on in there, and I can switch those over to, you know, follow the surface and whatnot. But you know, for something like this, what I would rather do is break this up into two portions. So what I'll do here is let's just turn off that toolpath, and we'll do the same thing. And for my drive, I grab just the top half of that cone. My start will be the top, and my end is going to be down here. And we'll grab that same cutter here. And we'll switch this over to spiral. Okay, so now we have real nice looking toolpath going down up to that circle. So now I need to finish that portion off. So what I'm going to do is I can do save and copy, or I can start a new operation here, and we'll kind of leave it where we left off with that first one. So if I go to my geometry and just grab that bottom piece here, and now my start's going to be where I left off with that original, and my end curve is going to be this kind of hex going on here. And we'll put this back to spiral again. I'll grab a tool real quick. So this is going to be a much more ideal cut for this particular part here. So you'll see that before, let's turn these off here, my hex was coming way up, even up into my circle here, and I'm not going to get a good surface finish when I'm doing, you know, especially these square points right here on a radii. So like I said, best thing to do is break it up into two pieces here, and so we have a nice smooth cone working our way down here. And then since my new start is where I ended up at with the previous operation, we're going into the circle, and now as we get into those hexes, it starts transitioning over for you guys. So just kind of thinking, you know, couple different ways to program stuff. Like I said, we could do, parallel to a curve on this one up here and get the same result, or do morph between boundary curves. But like I said, as the transition goes through here, we can tell it to, we'll get into a lot nicer surface finish as it's following that. Now, like what Ronnie was saying too, is if we want, and let's just do it as a test real quick here, is let's just do a circle. Yeah, we'll just do a circle like that. And I'm just kind of curious to see if we could clean up that first initial toolpath, or what we'll actually get here if we use that as our end. Definitely get a lot of bouncing around there. And what's going on there is, let's try cleaning up a little bit more. We'll do it at exact. So it cleans it up a little bit here, but we're not getting down, cutting our hexes like it should be. Let me just kind of zoom this part around here. Yeah, we're definitely not getting down into our hex area, just because it's trying to follow that circle geometry with that square, or that hex side of things. So, like I said, definitely the best thing for you guys to do is kind of, with this one, is kind of break it up into two portions here, and you'll get that really nice surface finish that you guys are trying to achieve here. So, any questions on this part here? All right, we're blowing through this tonight. All right, let's go ahead and hop out of here. And now we will get into morph between adjacent surfaces. Okay, so right here, morph between boundary curves and morph between adjacent surfaces are extremely similar. This one's a little tough to find out, a good part for you guys also right here. And, the morph between adjacent surfaces is really built for the, or it was really built for the 5-axis, doing like impellers and stuff like that. But you guys can most definitely use it on, as, morph between boundary curves too. And this is one we'll really get into more when we get it cutting into the 5-axis, especially when we get into the impellers, because this kind of is where the specific module is kind of built for here. But we can definitely use it in, a 3D setting here. So what we'll go ahead and do here is do a HSS, and do, yep, we're set on adjacent surfaces. And so it basically kind of the same thing. Click your drive. What areas do you want to cut? Your start surface. So we can do, we can do the left side. We can do the right side first. Totally up to you how you guys want to do it. We'll grab that as our end. And we should get the exact same results here. This is actually, if you guys can picture this, if anybody's into the dirt bike or the snowmobile world, this is actually the piggyback shock in the reservoir, the cap piece for it there. But there's a part sent in by a customer. And let's go ahead and grab a cutter here. And let's just see what we have so far here. Okay, so you'll see we're following along our surfaces here. Let's get our toolpath cleaned up a little bit first before we dive too far in here. So I'm going to go to my links, and between slices we'll just do blend and blend. Okay. So you'll see we're following the contour of that circle kind of going on right here, getting that radii cut out right here, and just working its way back. Now as it gets into the center, our toolpath actually straightens out here and now starts curving back towards this surface over here. So like I said, real similar to morph between boundary curves, but you can also think of it as this is a check surface too. So when you guys go to click on the surface, it's actually a check surface. So if you go to, it would be the same thing as if you guys came over here and turned on your gouge check for your check surfaces there. So it's not going to touch that wall at all, but it's going to get right up next to it. And this one I had to do a little bit reading up on, and you know, the specific terms is the toolpath is generated between the check surfaces and evenly spaced over the drive. So like I said, it kind of uses this as a check surface. This is the drive that you want to cut, and just cuts into everything in between, following the contour of what's going on there. So now this is something a little bit funny here. So when I first got this part from the customer, I was kind of noticing, you guys will kind of see right here, I've actually got toolpath that looks like it's going through the part. And so what I did is, you know, I came in here and turned on my drive, or my gouge check, you know, save and calculate again, and it's still showing up for me. Well, one thing that I wasn't watching for is, as I zoom out, you guys will see my toolpath all reappears. As I zoom in, it kind of goes away. This is kind of a SolidWorks setting here under your, let's see, is it performance? So if I move this to, you know, more accurate, then it will show up, you know, like it's supposed to. But something to do with this particular part and the accuracy of the SolidWorks model is actually showing it sinking in there. But let me just play this one through and we can actually see it too. Simulate this. Well, I'll just have to give it a second to update from that 3D machining here. Okay, so got it nice, clean, and cut in there. And like I said, we're still stepping over fairly large right now. If we do a stock target comparison here, you know, everything's right up to size. And I got my tolerance set a little bit large right now. Now, it looks like in the center here we could be leaving just a little bit material, but we're at 4/10. I have my accuracy set to 1/1000, so it could just be a tolerancing stuff. But to get, you know, like I said before, if we want to get that smooth, beautiful finish, last thing I want to do is come in here and change up that step over there. And now if we do a simulate, and get nice and cut in there. Just trying to see if it's just graphics. Yeah, it looks like we're all good here. Looks like it's just the shiny part of the center here. It looks like it's almost gouging in. I don't know if you guys can see that or not, but let's go ahead and do a stock target comparison here. Yeah, and we're cutting, you know, right up to size. And like I said, you know, I have my tolerance set at 4/10. So if I'm seeing any yellow, orange, or green on this particular, or light green on this particular part, I'm pretty much machined right up to size here. Now, obviously, I got a darker blue here where I got some material left over, and on my threads still got material left over, but I just did a quick 3D eye machining to get all that material out of there. But yeah. Any questions, guys, on this part? Unfortunately, this is the only one I actually have for morph between adjacent surfaces, just because they're so similar between morph between boundary curves versus adjacent surfaces. And like I said, the morph between adjacent surfaces is more geared towards, you know, the 5-axis impeller portion of it. And like I've said before too, is the only difference between HSS and 5-axis is just in your tool axis control. There's another box that's opened up right here. So for those of you guys that are a little intimidated by the 5-axis, once you if you can get through the HSS, the 5-axis is pretty easy for you guys. So, but any questions, concerns? Anything that I missed or that we should recover here? Said a little shorter than normal here. Not going the full hour, looks like, with this one, but try to give you guys as many parts as I can to show you the difference here. And like I said, with the morph between adjacent surfaces and morph between boundary curves are so similar that you know, you're not much to tell the difference there, I guess you could say. But like I said, it is using in these circles as check surfaces. So, no questions, guys? I see we got a couple people that have hands raised.
I don't. Let me see here. I've got a. If the tool. All right. So if the tool is y-axis, so what do we do? Is the question from Mr. Desai.
If the tool is y-axis, so what we do? I guess I don't quite understand that question. Can you give me a little bit more of what you're looking for?
We'll see if we just hold on and see if we get a response from
and
here, and I'll chime in if we've got it.
Yeah, Mr. George Lauer, I opened that big file that you sent me, and yeah, I think George sent me this file, and it's a character. I can't think of the name of the character right offhand, and I'm sure he'll pipe in and tell me what that character's name is. The character came in at, was it 56 feet tall, I think it was? It was an STL file of, I can't think of it right offhand. Trying to think. Here, let me, as long as we're kind of waiting here. Yeah, Baby Groot, there you go, from the Guardians. George definitely was not lying there. That file is massive. Like I said, I think I measured him out at 56 feet tall. So sorry, George, I don't think we're going to be able to machine that one for you.
And I do have a question here, Kev. Have you ever tried to cut an angled bore through a part with a ready-used key cutter? Gentleman says, and this is Mr. Kananan, I have a program ready for a part right now, and it looks good. I've never tried to use a key cutter in this fashion.
Oh, so using a key cutter, like let's see. Yes, I mean, to answer your question, yes. That's where you're going to want to use your Keyway cutter is your morph between boundary curves. I guess I don't have a Keyway cutter set up here, but you know, the inside curve is going to kind of be your start and end. Now, one thing I've kind of lost a little bit of focus on, and I should have had a part built for it, is HSS is the only toolpath out there that will do undercutting. So if you guys had a taper, if this cone was actually a taper going down at an angle here, and you guys were using a Keyway cutter, or like a lollipop cutter, HSS is going to be your only one that you're going to want to use. And for that angle, let's see, let me just kind of reread it here. Have you ever tried cutting an angle bore through a part using a radius Keyway cutter? Have it programmed ready for a part right now? Just look, and it looks good. I've just never tried using Keyway cutter in this fashion. Yeah, and to kind of, the key cutter is kind of like a slot mill with a full radius. So let's see, we are at a 0.25. Oh, no, I did cutting height there. Here we are. So is this kind of what you're using right now? It looks like, okay, sounds promising. This is the same way I programmed the part.
Yeah.
Timing. Okay. So yeah, what he's trying to do is he's taking a full radius keyway cutter and coming in at different angles and stuff like that, and absolutely, especially if you guys are, like, I don't know if you guys can see my mouse over here, but where my mouse cursor is, if you guys are cutting like a radius like this, definitely you can use that tool. Same thing for, like I was talking about, doing those undercuts. This is going to be your go-to tool here, or like I said, a lollipop cutter. So when you're doing that cut, just one thing to keep in mind is, let's see, no, we don't want to save it, is make sure when you're doing that cut, you go to your sorting and switch it over to a spiral. So you keep that tool, can't even talk tonight, that tool in contact, doing a nice spiral in there, and you should come out with a really nice finish for you. So. Oh, George said it was 56 millimeters high.
Yes. Yes, he did.
And if you guys want, I can, give me 1 second here and I can. Big file and baby root.
Groot.
Or Groot. See, I don't even know what these characters are.
Yeah. You're missing out, man. You go see Guardians.
Yes.
Oh, that's awesome. That is awesome.
So here is baby Groot. And now if I click, I could have sworn I measured this out and it was much taller. Let's go to measure here and go to the bottom of his butt here. Oh, it's a mesh. I can't get it right now, but so there's baby Groot, or did I say it right?
Groot, yeah, Groot. You got it. That is fantastic looking too. That is, absolutely.
So, okay, Ronnie got on. You can also use a circle segment cutter. One example is a barrel type. It has a large 2-inch radius. Ronnie, do you have a picture of that cutter by any chance? Ronnie's given a recommendation of using almost a different tool here. Barrel type. Okay, so he's telling me go to a website here.
Yeah.
So let's just type in MU. And in mills, barrel type is essentially a lollipop with a lips instead of a full circle. Okay.
He's giving you a link there. Yeah.
Thank you, Ronnie. I'm really curious to see what this tool looks like. So is it a taper kind of ball right here? Because it looks to me, I'm looking and it just has a quick barrel. Okay, so it gets wider right here and then narrows down. Okay, God, I've never seen a tool like that. Huh. Very cool. Let's see. A few months ago, there was a big article on them in Modern Machine Shop, and I would assume these tools work great. Obviously, they're doing a write-up in Modern Machine Shop, so For Mr. Canyon, sorry if I butcher your name here, definitely. Let me put this link in the GoToMeeting chat so everybody can have it here. And that way you can try that out too. But yeah, thanks, Ronnie. Cool. Any other suggestions or tips, tricks, anything else? Much faster than the lollipop or ball end mill and more engagement. Yeah.
Okay.
Yeah, that's God, I've never seen a tool like that before. That is definitely cool. Ronnie, do you know, or George, do you guys know how much, like are they pretty expensive or?
And Jeff just said he's asked if we could add that as a tool type a few months back.
So with the tool types, let me just kind of pull up something here because I'm kind of fighting for this right now. Right now, what I would like to see, I'm trying to get them add in here is a radius cutter. So instead of having to come in and build a shape tool to do a, if you guys had a radius around here as a radius cutter. So now I guess this is just maybe because I've been out of machining for a year or so. Is this a really common tool that you guys are using? Because I mean, obviously I got Jeff and Ronnie and George all writing about it.
And
what is the lead tech guy's name? Ronnie, corner rounders, yes. Common for 5-axis, okay.
Yeah.
Russ. Yeah, what about Russ? Oh, okay.
So Russ can get it going.
Okay. Yeah. There's a CAM system, that one. Oh, okay. Huh. So yeah, I'll definitely have to. I'll put this in as a request for a feature request to get that barrel cutter added in there, and so it will be part of our tool library here. And like I said, I'm trying to get the corner round tool in here also for you guys because I know that's a real common one. For those of you guys that are unsure as it sits right now with those corner radius cutters, if you go to my channel and type in shape, right here is making that shape right now. So definitely check it out. And like I said, this is I'm trying to get this added into the library, so it'll be there for you guys. And then all you guys have to do is just type in diameter, radius, tip diameter, and it'll build that tool for you instead of coming into the shape tool. And I'm kind of went along that same long lines, Ronnie, except you probably did an import with Russ on that one.
And Jeff just asked if the corner round will be able to have flared edges.
Oh yeah, yep. Yeah, we'll get that all added in there. Like I said, it's all in the process of feature request. So, and like I said, in past webinars, guys, you guys giving me input on the program is, our slogan is, #1 in integrated CAM software, but I really want to push more of the customer-driven CAM software. So, definitely I will get these all put in for you guys for this, this barrel end mill right here. But if, like I said, with anything in the software, there's something that you guys are seeing that you want to see added in there, or, something changed, definitely let us know right away, because we can put that in to development, and they usually turn that around very, very quickly. So, all right, let's see, import and taper end mill, push on expansion of transforms. Is that Ronnie, is that what you're saying, how you built that tool? Yes, okay. Perfect. No, sounds good, guys. I will definitely put this in as a feature request, and like I said, any other feature requests that come up, you know, definitely shoot those over to me in via email, and get those added in there for you guys right away. And I'm glad you guys pointed this out because I've never seen this end mill before, so it's a little news to me too. But all right, guys, any other questions before we end this for tonight? Lots of great talking stuff tonight. I really appreciate all the input from you guys too. And
Yeah.
Let's see. Yeah, absolutely. Now, Ronnie, with that that $250 you were saying, is that a custom ground one from just a local shop that made them, or is that a custom ground one from this actual website right here? Custom ground, okay. Five-axis machine. Okay. No, great input, guys. Definitely love it. All right, guys. So I will get this turned in as a feature request for you guys too here, and when we hopefully it will be added in there. So when we go to do the 5-axis work, we can actually use this cutter too. So, but until then, definitely I can't thank you guys enough for you know, sitting in on your Wednesday night and listening to me teach here, and hopefully you got something out of it. Now, next week we are going to be covering the last portion of HSS, I think. Yep, so we're going to be doing projection, user-defined, radial, spiral, and offset. I think I have these all grouped for together. I can't remember right offhand if I did group these all together in the class or not, but yeah, we'll be covering these next Wednesday, so definitely check it out there. Looks like Carlos gave me a website. Oops, I'm getting lost here. Check out video. Let me just grab this for you guys real quick. Oops. Oh, here it's talking about it. So it would actually work good for porting also, looks like. Yeah. So for those of you guys that are interested, I will put this article in the chat, and everybody should be able to see that link in the chat. Now, unfortunately, once I go to close down this webinar, those links will go away. So if you guys do have, if you guys didn't get a chance to click on it, shoot me an email and I can send you the link also. Let's see, he told me to fast forward about 5 minutes here. Oh, that one's not even 5 minutes long. It must be, am I in the right video here? Must have been,
there you go.
So let's get to 5 minutes here. Looks like it's kind of the end of the video. Yeah, there's a lot of stuff on YouTube for you guys to check out. So, but definitely looks like this one is a good article here talking about that that barrel cutter. So definitely check it out. But and am I missing anything? Any chance you could do a video or show next week using a lollipop end mill? Absolutely. Yep. Do some drilling through pipes. George, copy what you just sent me in the comments right there. Copy that out and send that to me in the email if you could, please. Because like I said, once I end this, then I lose all our chat conversations here. So definitely send that over to me. That'd be great. But all right, guys. we'll wrap it up here, and like I said, thanks again for joining us for the night class here. And like I said, any questions, concerns, definitely let me know. Send those ideas over to us. Something I haven't showed for quite a while here is, if you guys like the software, tell your buddies about it. We'll give you the KevCAM Special, and you just give us a name and a phone number of that buddy, and they sit in demo, you get $100, and then if they buy, you guys get 20% of that sale. So pretty good deal. Kind of forgot about this here, so like I said, I was able to get the CEO of the company to up the Benny value for you guys for doing the night class. So definitely let your friends and family and dad and everybody know about it. But all right, guys, have a wonderful night, and thanks again for stay tuned into the night class.
Thank you, gentlemen. You guys have a great night.
All right, bye, guys.